Hey, so in this video, we are going to continue moving forward in our graphs curriculum. And specifically, we are going to look at a couple of different algorithms that can be used to search or traverse our graphs. So at the end of watching this video, you should feel comfortable with one particular searching algorithm known as breadth first search. So you should be able to describe it, talk about when we would use breadth first search, and manually trace breadth first search on a graph. So let's talk a little bit about what this searching algorithm actually is. Okay, so all it is, it's an algorithm that we can use to look through a graph and find a solution to whatever problem it is we're trying to solve. And the way that it works, it's actually going to explore all possible paths in the graph to find the one with the smallest weight, and the way in which it will traverse each path. So it is going to, you can think about it, it searches across before searching down. So in breadth first search, we explore all the nodes on the same level of the graph before moving down to deeper levels that are further away from the root. And we'll look at some visual examples of this as well. And as it does this, it does not need to re-explore or research nodes. So whatever the size of your graph is, in a worst case scenario, breadth first search would need to just look over each node one time to complete its search. So we can see here, so we've got kind of a visualization. So breadth first search is always going to start at the root node, which in this image is node 1. And then it's next going to explore all the nodes that are a distance of 1 away from the root, right? So all the nodes that are closest to the root. Then it will look at all the nodes that are next closest, so it's kind of going down one level at a time. So you're not actually getting all the way to the bottom of a branch, so like nodes 9 and 10 that are all the way down at the bottom of that graph, they are some of the last nodes to be searched if you're using this particular searching algorithm. There are other algorithms that will go down a branch and get to the bottom of your graph earlier if that's something that you might need to do. All right, so why would we use breadth first search? What are some of the real world applications of this algorithm? It can be particularly useful for route finding or path finding problems. So if you think, for example, I need to find a route from one city to another, it makes sense to start exploring all the routes closest first, all the roads closest first, and see if, okay, will this road lead me to the city that I'm trying to get to? Okay, so that's one example. Breadth first search can also be used in social networking. So think about all those suggested friend notification pop-ups that you get on various social networking sites. How do they determine, you might know this person? Well, it's likely that they're using some type of graph and they're saying, using a breadth first search, this person is, only 1 or 2 connections away from this other person. There's a good chance that they might know each other through this mutual friend or mutual friends. And there are also some applications in networking as well. Okay, so now let's get into this specific algorithm and actually go through and run a sample breadth first search. So we're always going to have a starting vertex that is given to us. So on a tree, this would be the root of our tree. But if we're working with a graph, an undirected graph, then we would have a starting vertex labeled so that we know where to start. And then this is kind of the loop that we're going to repeat over and over. So we're at a specific node or a specific vertex, we're going to explore that vertex. What that entails is while there is at least one other vertex adjacent to this that we have not marked to explore, we're going to schedule. We're not going to explore it right this second, but we're going to kind of jot down this vertex off to the side. Hey, we need to come explore this later. Okay, and specifically, we're going to use, you can use a queue to implement that scheduling. Okay, and then so you'll continue to schedule all the vertices adjacent to your current vertex, and then once you've scheduled everything around whatever vertex you're currently exploring, you can mark that vertex as explored, remove it from the queue. You don't need to come back to it. Okay, so what does this actually look like? So here we have a directed graph with a few different locations. I'm going to say the starting vertex is home. Okay, so using breadth first search, we're first going to explore home. We want to explore our starting vertex. So we need to look around and say, okay, have we explored all the nodes adjacent to home? And it looks like we have not. I'm going to kind of color them in as we explore them. There's a white, gray, black coloring scheme that's pretty commonly used. So right now we haven't explored anything. So all the nodes are white to indicate that. So we put home onto our queue. I'm going to mark it as gray right now because we've scheduled it. We're in the process of exploring it, but we have not finished exploring it yet. Okay. Now I need to go and schedule all the nodes that are adjacent to home. So I look one way, I see, okay, school is adjacent to home. So I'm going to go ahead and schedule that, add it to the queue, color it gray to indicate that it has been scheduled. We will go and explore it later. Okay, I look in the other direction. I see there's one other node that is adjacent to home that we have not scheduled. That is the store node. So I'll go ahead and do the same thing, color it gray, add it to the queue, and we'll come back and explore this later. So now if we look at our home node, and we revisit this question that we asked at the very beginning, okay, are there any adjacent nodes that have not yet been scheduled? Well, there are only 2 adjacent nodes, and now we have scheduled both of them. So at this point in time, we can go ahead and say home has been thoroughly explored. Okay, we have scheduled the nodes adjacent to it, so we're going to do 2 things. We're going to mark it black to indicate that it has been explored. We don't need to revisit it. And you'll also notice that we removed it from our queue. Okay. So now, when determining which node to explore next, we're going to go ahead and look, okay, what is now at the top of our queue? Because remember, with a queue, we're following first in, first out, right? Just like a line. So school is next, so school is the next node we will explore. It looks like there is one node adjacent to school that we have not scheduled yet. So that's the work node. So we'll go ahead and color that, add it to our queue. Now, because there are no other unexplored nodes around school, we get to go ahead and pop that off the queue. Okay. Same thing now, we're going to go check the top of our queue. Store is the next thing to explore. We look at the graph. We've actually already scheduled everything adjacent to store, so we can go ahead and remove that from the queue. The very last node we have is work. There are no unexplored nodes adjacent to work, so same thing, we can go ahead and remove it from the queue and color it black. So at this point, we have traversed our graph using breadth first search. So to wrap it all up, okay, so breadth first search is just one algorithm, one way that we can traverse our graph. We're always going to start at the levels closest to the root, explore all of those levels completely, and we're going to explore the nodes furthest away from the root at the very end. Okay, so why this is important? So there are certain problems that breadth first search works well for, and other problems where it might take a little bit longer. So for example, if you are solving some variation of the shortest path problem, or some other scenario where you know the solution will be relatively close to the root of your graph or the starting node of your graph, this is a good method to use because other searching algorithms like depth first search will not necessarily find your solution as quickly. But if you are doing something where you need to get all the way down to those leaf nodes in your tree, or those nodes that are very far away from your starting vertex, breadth first search might not be the best tool to use.